Flight simulators, you know, everyone loves them. I love them, but they're only for the most mature and sophisticated gamers. You know, people that really want to get that real flying experience. Barrel roll! And they're so much more peaceful than regular games. You know, you can relax while you're playing them. So I actually do really like playing flight simulators. However, what I don't like doing is paying like $250 for a flight yoke that probably costs someone like $2 to make. So, like anyone else in their right mind, I decided to make my own, of course. I'm taking a Arduino Micro and I 3D printed a bunch of parts and made this here flight yoke and then these rudder pedals. So of course I'll be posting all the files for all of this so anyone can print it if they want, as well as the step files so they can, you know, modify it and make it their own if they would want, which I would highly encourage. I'm also going to show kind of like a build montage of how these go together, and just in case it helps anyone put it together. So without further ado, let's get into the building. So when I was building this flight yoke, I was trying to do it for as cheap as possible. That means I ended up using a lot of hardware I had laying around already. You'll notice that a lot of the parts come from old 3D printers or past projects that I've done. This bearing housing is what the flight yoke will end up attaching to. It allows it to rotate, but also constrains it to a 45-degree rotation in each direction. I am adding one of these 6mm hubs to the back of the shaft. This will allow us to attach a potentiometer later. The Arduino will use this potentiometer to know the position of the flight yoke and send that position to the computer, which will then control the game. Here is the flight yoke that I 3D printed for this project. I found the original model on GrabCAD and then modified it to fit my purposes. I built in 2 buttons to the flight yoke. In the game you can actually map these buttons to whatever you want, but currently I have one of them set to the brake and one of them set to changing camera angles. To allow the flight yoke to slide linearly, we'll use 2 of these linear bearings and then 2 steel shafts for them to ride on. These are parts that I harvested from an old 3D printer of mine, and they should allow this flight yoke to slide smoothly without any excess friction. Here I'm attaching a piece of aluminum extrusion to the sliding piece, and this will eventually attach the sliding piece to the flight yoke. I use this because I ended up having it left over from an old 3D printer I took apart. However, I would recommend using whatever you have. Anything will work here. I mean, you could even use like a piece of wood if you wanted to. To allow the Arduino to read the linear position, we're going to use a rack and pinion system. This consists of a potentiometer, which is attached to a 3D printed gear, aka the pinion, and then a long, straight, flat, quote-unquote rack, which is attached to the base board of this entire system. And so the rack will rotate as the flight yoke is pulled in and out. On the lateral axis, I also added some rubber bands to make the flight yoke kind of self-center to the 0 position. I didn't do this on all of the axes, but on the lateral axis it made sense, so I did it. So along with the flight yoke, I wanted to add this kind of throttle control box. I ended up deciding to have 3 levers, and currently I have them hooked up to throttle, flaps, and slats. Obviously in the game you can program them to be hooked up to whatever you want, but those are just the 3 that I have them attached to right now. There are also 4 different buttons / switches, And for each of those buttons / switch, I put a LED indicator to tell you whether it's on or off. And those are also programmable to whatever you want in the game. But currently I have them hooked up to parking brake, landing gear, and there's a couple extra ones that I haven't hooked up to anything yet. I also decided to add these kind of fancy color knobs at the top. The only thing they do is really just help you identify which lever is which, and then you can grab it a little bit easier, but they're not that important. So to take all the positions of the various controls and then relay it to the computer, we need like a microcontroller in the middle. So luckily, Arduino makes something called the Arduino Micro, which has a built-in USB interface, which means that it can talk to the computer and the game can recognize it as a USB device. And it also has enough analog and digital inputs that we can read in all the signals from all of our controls. So I know I've been asked a couple times in the comments to explain things a little bit more, so I'm going to try to explain how a potentiometer and an analog input works. So a potentiometer will have 3 pins, a reference voltage, ground, and then a voltage output. Inside the potentiometer, the voltage reference and the ground pins are connected to either end of a resistive strip. The middle pin is attached to a wiper, which rotates as you rotate the knob of the potentiometer. As the wiper moves along the resistive strip, the resistances will change on either side of the wiper. This essentially creates a variable voltage divider circuit, which changes the voltage on the voltage output pin between voltage reference and ground. Now, the chip that the Arduino Micro uses, which is the Atmega 32U4, has a 10-bit analog to digital converter built into it. This means that it divides the difference between the reference voltage and ground into 1024 segments. As the potentiometer rotates and the output voltage changes, the analog input will read it and output a number between 0 and 1024 into your code. The range of values these analog inputs will see during normal use of the flight yoke can then be inputted into your code as the axis range. The more steps that this range is divided up into, the more resolution that your controller will have, and in theory, the smoother your movements will be. This resolution is one reason that I initially wanted to use an ESP32, because they have 12-bit analog to digital converters in them, which means you get almost 4 times the resolution. However, ESP32s don't have a USB interface built into them, so it wouldn't work for this application. So luckily there is a library that does most of the work for you when turning the analog signals into a data stream over USB that the computer can read. Now, I'm not actually the first person to use this. I'm far from it. A bunch of other people have built similar systems for games, etc. And most notably, Tom Stanton made a video, I think about a month and a half ago, and he actually made a flight like stick, kind of like you'd see in like a bush plane, rather than a flight yoke. But I decided I wanted an actual flight yoke, so that's why I built my own. That said, he does offer some really good explanations on how some of these things work, so I'd highly recommend you go check out his video. I'll put a link down in the description. He also released all of his CAD and code files, so if you're more interested in making like a flight stick rather than a flight yoke, I would definitely go check out his video. I'll put a link down in the description. The code I used for this project actually started off as the same code that he used, and then I obviously modified it to fit my purposes and have it be on a flight yoke rather than a flight stick. When I was designing the rotor pedals, one thing I wanted to make sure that I captured was the actual movement of rotor pedals. It'd be a lot easier, for me at least, just to make it, pivot and go up and down. However, I wanted to make sure that they actually laterally slide like they do in planes. So I ended up with this design of 2 pedals that slide back and forth on 8mm steel shafts, kind of just like the lateral axis on the yoke. However, in between the two pedals, there is a center crossbar that is supported at the center in some bearings, and then there's a gear that gears up or has a geared ratio so that it spins a potentiometer a little bit faster than the center of the bar is spinning. This allows us to use the full 180 degrees of the potentiometer without actually spinning the center bar 180 degrees. I also added some rubber bands to these rudder pedals, that way they self-center to the 0 position. Alright guys, I hope you enjoyed the video. I put all the files, including the STL files, step files, and all the code for this below. So check those out if you're interested, and then I'll see you in the next one. Peace.